Okay, it's time for circly stuff, but now with area. We spent a whole lot of time talking about circles before, but we never found the area of anything. So here it comes. All right, you probably have heard about this before. Area of a circle is pi r squared. That's to find the entire area of a circle. Some of you accidentally said that a lot when we were looking at circumference back in the other unit, where it was, wait a second. What's that? Oh, yeah, when you were talking about circumference, you were supposed to say 2 pi r. Rearrange those symbols, we get pi r squared. That's very confusing, but realize area is a squared phenomenon, so it's r squared is the one that's attached to area. That's going to get more confusing when we come to the final in June. All right. What is this about? I've never seen this before. That's what caused me to stop. Area equals pi d squared over 4? Oh my gosh, forget about that. Just focus on this. Area is pi r squared. Great. So that's the easy part. What's this? Oh my gosh, just a second. Sorry about that. Computer had a mind of its own. The interesting new kind of harder part of this lesson is about sectors of circles. Sector of a circle is the region bounded by 2 radii and the arc. So something like this, or actually this white Pac-Man kind of shape over here is also a sector. Sector has a corner at the center of the circle, radius, and goes out to the circle like some sort of pizza slice. Okay. Since a sector is a portion of the circle, we can find its area as we did with arc length by finding the fraction that it is of the entire circle by looking at this angle in here. So we did that exact same x over 360 business when we were trying to find the length of this arc. We said this arc was x 3/60ths of the circumference of the circle. The area of this arc is x 3/60ths of the area of the circle. So that's actually the same sort of trick we're going to use to find that portional area as we did with the portional length when we were talking about that over there. For example, we do area first and then we do a sector. All right, calculate the area of the circle with diameter 6. Need to get out my handy dandy tablet. Okay, diameter 6. So this entire, there it is, the pointer. This is 6. Well, we want area. Area is pi r squared, but this is diameter, so we actually want radius. Radius is 3, so we want pi times radius squared. You can leave it just like that, no problem. That seems like child's play when we start getting to sectors. All right, 6 ounces of dough is needed to make a round pizza with a 6-inch radius. How much dough is needed to make a pizza with a 12-inch radius? Well, you probably want to say, oh, that's probably 12. Well, let's check it out. Really, the amount of dough we need is going to have to do with how much area is in this flat circle. And we're going to see how many of these flat circles do we need to cover this flat circle. And the only way we can really do that is find the area of this, find the area of this, and see how they compare. Okay, the area of this circle over here is pi times 6 squared, which is 36 pi. The area of this circle over here is pi times 12 squared, which is 144 pi, which is not just double of 36 squared. How many 36 squareds does it take to make 144 squared? Well, we can just divide and find out. And we get 4. So that means there's actually 4 of these circles that fit in here. So how much dough we're going to need? Well, it was 6 ounces of dough to make the little one, so it's going to take 4 times 6, or 24 ounces of dough to make the big one. Okay. Here we go, sector. This is the fun stuff. All right, the area of this sector is 63 pi over 2, which seems like a really crazy number for it to be, but actually when we go to do the algebra, that's going to be helpful that it's got pi's and fractions in it. All right, first of all, find the length of AO, and then find the area of the circle. All right, let's do the sector area first. Sector, as you remember, was the fraction out of 360, the degrees out of 360, times the area of the circle. Well, we know sector area is 63 pi. I'm using that because this is going to help us solve for radius, and that's the first thing they ask. This, of course, is radius. 63 pi over 2, that equals all this same stuff, times pi times r squared. Oh, wait, I don't need to say x. I know what that is. What's the degree there at the center? This is 140. They told me this is a 140-degree arc. Well, yeah, well, that means it's 140 degrees at the center. Okay, and I want to solve that by first canceling the pi's. And then I can kind of reduce this. This is 14 divided by 36. I mean, really, at this point, it's algebra. You could put this in the calculator. It would do it for you. I have 63 over 2 over here, and I have, if I reduce that, I can divide by 2. 7 over 18 r squared. I can kind of reduce this some more. I can multiply both sides by 2. That becomes 9. That's gone. Divide both sides by 7. That's gone. This becomes 9. I get 81 equals r squared, so r is 9. That's lovely. See, remember how gross this looked at the beginning? Well, it turned out we got a nice value for r. Again, when you got to this step right here, you could just put the whole thing in the calculator and hit solve, and you'll get 9 equals r. Or you could try to do the algebra like I did. That's fine. The area of the circle, well, that's just pi r squared. And we know what the r is now. It's 9. So let's leave it like this. All these ones with pi in it, as you know, you can get a decimal answer if you like. I would rather have you do the pi in there. Easier to grade, easier to be exact. All right. Oh, and here we are at the end. This is the last question already. Wow. All right. Find the area of the shaded region. Given that the circle T has radius of 7, and there's this triangle that's perfectly tangent at these 3 places, and it's, of course, equilateral. Okay. So this is one of those composite shapes, technically, from like last section. All we're going to do is take triangle minus circle. And all we know is that the circle has radius, and I can draw that radius wherever I want, radius of 7. So the circle's the easy part. Pi r squared, great. That's easy. That's pi times 7 squared. That's 49 pi. That's the circle. Great. The hard part, I think, is the triangle. The triangle is half times the base of the triangle times the height. Well, the base of the triangle, ooh, that could be kind of tricky. This is 7. Remember, I could draw that radius wherever I want. If I want to think about a triangle like this to try to help me figure out what the base of that triangle is, PR, well, this isn't so bad, because what kind of triangle is this? Well, this was 60 because it was equilateral. That means this has to be 30. So I'm looking at a 30, 60, 90 triangle with a short side 7. Oh, good, the short side 7. So that means long side's 14. Weird side is 7 square root 3. This entire base then is just 2 of those. 14 square root 3. Okay, so that's half the battle. I just figured out that the base of this is 14 square root 3. And what's the height? Ew, the height is from here all the way up to here. You know what? That point, that distance from T to Q is got to be the same as the distance from T to P. If T to P is 14, T to Q is 14. So this entire height looks to be like it's 21. It actually is. Okay, half times 14 times 21 times the square root of 3. Put these minuses in here. Is 7 times 21, which is 147. This answer is exact. You can leave it like this. There's no problem with that. Great. And for the first time in a while, I have a lot of time left to talk to you. I have another, 6 minutes. Anything else that was kind of scary back here? Let's go back and look. That wasn't scary. I think this was probably the scariest thing. Like, why did we do this division? Why did we do this multiply thing? And here to figure it out. I know that this 36 pi square inches corresponds to a dough amount of 6 ounces. I know that this is the same as 6 ounces of dough. The question over here is this 144, that's the same as how many ounces of dough? So what I tried to do there was kind of make a proportion here. I said, well, 36 is what fraction of 144? 36 pi is what fraction of 144 pi? And I figured out that it was 1/4, basically. That you need 4 of these to make one of these. So let's just take this times 4 and figure it out. And I think for this type of problem in this chapter, that's about as hard as it's going to get. I don't think you have to get a whole lot more technical to figure out these types of problems. Since I have the time, I'll just keep clarifying things. I always feel like I have to speed up so much in these, and then I get to the end, and then it's like, ooh, we got to finish because there's 15 minutes in the video, and I got to finish it so fast because the software cuts me off at 15 minutes. I've got all this time now, so, yeah, I think this is pretty straightforward. Again, I think the hardest part here was this algebra step. 63 pi over 2, excuse me, equals this fraction times pi r squared. There's a zillion ways you could decide to start canceling things out and simplifying things. You can just put the whole thing in the calculator and say, solve me. Or you could put this in the calculator and see if it simplifies and see what happens. I don't think that's going to simplify. Put this in the calculator, hit enter, simplify, see what happens, see what you get. You probably get something like 7/18 pi r that would help you out a lot if you can't use the solve command on the test, which sometimes we don't let you do. Anyway, algebra questions, just come to one of us if you have algebra questions, and we'll show you how those work. Okay, I'm done rambling. That's enough of your time I need to take. See you in class.